Okay, so the instruction is evaluate. Okay, so the first one, square root of 16 plus 9. Let's try an answer. Who has an answer? Just shout it out. 5. Anyone have a different answer? 7. So which is right, 5 or 7? 5. More people said 5. How did someone get how do you get 7 from this? Right, and that's the wrong way. So this is equal to, you have to do, this is like a bracket, remember, and you always do the inside of the bracket first if you can. So this would be 25, which is equal to 5. This is a different question. You have to do each of them individually. So 4 plus 3, which is 7. Okay, those are two different questions. Okay, so be careful of that. All right. So this one. So you don't split it up. You have to do the inside of the bracket first, which is 9. So the answer would be 3. Okay? So that's when there's a plus or minus in the bracket. So we could actually add a variable into that too. So what if I said 25x minus 25? This appears in calculus a lot. Now you can't break it down, and there's an x in it, so you can't add them together. So you can't do the inside of the bracket first, but you can factor out a 25. Do you notice there's a 25 in both of them? And we do know the square root of 25. So the way you would do this is you would say 25 brackets. So we're going to factor it out. If we take a 25 out of the first one, we're left with an x, and minus, and take a 25 out of the second one, we're left with a 1. And now, since these are multiplied, you can take the square root of each separate. So the rule that this comes from is this. If these two things in the bracket are multiplied, you can say this is a to the n, b to the n. That goes to our square root too, because the square root is a half power. Square root is an exponent, so that is the same as now what's the difference between this, I'm going to put wrong here, it's wrong to do this. Right, the plus sign here, you can't, that rule does not apply if there's a plus or minus in the bracket, but if it's times, you can do that. Okay, you can break it down to each. So back up here, what's the square root of 25? 5, and the square root of x minus 1, we can't figure out, so we just leave it that way, x minus 1.
You don't do square root, you don't do the 1 over 2, do the x minus 1? It would be x minus 1 over 2. You wouldn't do that? You don't know square root is...
So you could, this is the same thing, but there's nothing else you can do to it.
Okay.
Yeah. You can't apply that half to anything. Yeah, because there's a plus sign in between, so you can't break, or negative, you can't break it down. Okay, so that being said, what about this one? Square root of x squared minus 25. So you can't do that, no. because this is wrong. You can't split them up.
No, I don't mean like splitting them up, but you can still take the square root of x squared to be x, right?
No. Because there's not a square root over the x squared. It's over x squared minus 25. Nothing. There's nothing you can do. Although it's tempting because both x squared and 25 have a square root, but it's not, they're not separated. If it were written like this, that would be equal to x minus 5. But this is a different question. There's nothing you can do here. Okay, so what's the rule? You cannot break it up if there's a minus or a plus. If they're multiplied, you can. So let's write it as multiplied under. So let's say I have 25x squared. See, those are multiplied instead of added? What's the answer to that one? 5x, because you can take the square root of both 25 and x squared, so this would be 5x. Okay? So you can do it if they're multiplied, you cannot do it if they're plus or minus. So that goes for things like this as well. It's the exact same rule, because a square root is an exponent. You can't break this up. This is not equal to x squared plus 1 squared. This is not equal to x squared plus 1 squared, or x squared plus 1. You can't do that. How do we expand this? Write it out twice and then FOIL it out, which we're going to do in another section. But it actually has 3 terms, not 2. This is 2 terms if you just squared both. It actually has a middle term as well that you wouldn't see if you just did that by mistake. Okay, so that exponent rule works for everything. If it is added or subtracted, you cannot break it up. Okay, so what about this one? I'm going to write 2 of them down at a time. So here's 8 and 9. See if you can get the answer to 8. Who's confident with their answer in 8? If I had $5 right now to give you for being confident in the right answer, not that I have $5, but if I did, $5, $50 were on the line, could you get the answer to number 8? Only one person. Oh, there we go. All right. So there's no plus or minus signs, so we can take the square root of each piece individually. So you can do the square root of 49, you can do the square root of x squared, and you can do the square root of y to the 4. For the people not confident, how do you get the answers to these 2? What would be the long way to do it? Put it as a half power. So remember we did this last class. We said if there's an exponent here, 2, that's on top, the square root is a 2 on the bottom. And this would be 4 over 2. Four over 2 is 2. So the answer would be 7xy squared. Now what about the next one? You can do it, yeah. They're multiplied. I think you're thinking of a negative under the square root, but this is the same as, whoops, make a bigger square root there. The same as this. And you can do the square root of the top and the square root of the bottom. So multiply and divide are the same. Like that.
how'd you make the -2 positive?
Yeah, so the rule of negative exponents is if it's negative, you can move it to the other side of the fraction. So the bottom would be a 1 here because it's not showing. So we move it down to the bottom and it becomes a positive. Yeah. So if we had this 100 x to the minus 2, so you could write square root of 100, square root of x to the minus 2. This is 10. This is x to the minus 2 over 2. Minus 2 over the square root is 2, so this is 10x to the minus 1. Same question, different way. Yeah.
So can you just not find the square root if it's like a big number, so if it was negative?
Yeah, so let's do some negative ones. Yeah, so the number can't be negative. Where is my paper? Oh. So negative exponent is okay because that doesn't mean the number is negative. So what you're thinking is, like if I had the square root of -9, this, I mean, you maybe did imaginary numbers, but in calculus we don't deal with imaginary numbers, okay? So in terms of this class, preparing for calculus, this is undefined. So why is it undefined? Well, a square root, this is equal to 3. Why is it equal to 3? Since 3 times 3 is equal to 9. Right, if you multiply two negatives, you get a positive. There's no way to multiply the same two numbers. These numbers have to be the same to get the answer. So if we had square root of -9, well, 9 is 3 times 3, but one of them would have to be a negative and one would have to be a positive, and now those are not the same two numbers multiplying. One's a positive 3, one's a negative 3. So this is undefined because there's no way -3 times -3 is also equal to +9, so the square root of 9. Right. So you don't have a negative in it. If we were to draw a squared function, which happens in Chapter 2, okay, it looks like this, which is a half a parabola on its side. Okay, that's a square root function. Doesn't matter what x is. You change the value of x, these are the points you get. But if you notice, this is your x-axis, right? This is your y-axis. What x value is this right here? 0, 1, 2, 3. Over here is -1, but there's no graph there. That's because it doesn't exist there. And what about the y values? Down here is negative. What's up here? Positive. So x and so both the number you plug in has to be positive. X, we say, is greater than or equal to 0 for a square root function. But y, your answer, is always, so this is your input, or the number you plug in. And your x has to be positive. And your answer that you get out is also always positive. So like in a computer or a calculator, when you put in a number for the square root symbol on your calculator, your answer will always be positive, if it works. If you plugged in a negative and then did the square root, it would just say error, because it doesn't work. Okay, let's do... What do you think? -81 to the half. Yep.
I had a question regarding
Yeah.
that one actually. Could y actually be negative? Because you could have two negatives to come from two negatives to multiply to make your x.
Yeah, no, you can't, because the -3 times -3 is +9, and you can't get you can't show that, so it doesn't happen. You can't, I know what you're saying, but you can't, it's not -9, right? It's +9, and that's,
Right, but why
yeah.
can't one make that 3, couldn't it?
No, and it does, that does happen, the plus or minus thing. Is that what you're thinking of? That's when you're solving an equation, and we're going to do that later. I'll show you now because you're asking. So if there's an equation, rather than just an expression is what we have now, we're just solving a square root. And the only square, this you would just say undefined, that doesn't work, and this one is 3. Now if you had an equation, x squared equals 9, this can be both plus and minus 3. Why? Because you can do 3 squared and get 9 as an answer, and you can do minus 3 squared and get 9. Okay? So this x can be both plus or minus 3. And it does have a square root in it when you solve it, but it looks like this. The plus and minus are outside of the square root rather than inside of the square root. Okay, we'll do that in the equation section.
I'm
Yeah.
getting ahead of myself again. But the undefined answer, you got -9 square rooted. Couldn't you just do -9 if the exponent of 1/2? Since the square root turns into 1/2.
Yeah, but there's no answer. Like if you put that in your calculator, just this
Oh.
error. Yeah. That would be true. No. It's just rewriting it a different way, but it's not an answer. Yeah. So square root or a half power, you can write either way and it's still the same thing.
Even if you were to say,
And it's not more simplified or less simplified, it's just equal, like the same. Yeah. Okay, so we will see this, but it's not that a square root has 2 answers. A square root of x equals 3 has 1 answer only. And that is 9. But a squared, when you start with a squared, it can have 2 answers, plus and minus. Okay? But those are 2 different things. Okay, and I guess that's confusing. But we'll get to it later. Okay, what about this one? Right, this is the same as square root of -81, which is undefined. Now what about this one? -81 to the half. Is that the same thing as number 11? It's not. The bracket's different, and that bracket was holding the 81 under the square root. The lack of bracket is actually putting the negative in front of the square root, because the only thing with the half is the 81 itself. So this is negative root 81, which is -9. Yeah, yep. So a bracket around a negative includes the negative in that square root, which is not possible, but putting a negative in front of a number is okay. Because that's square root of 81 with a negative in front, multiplied by -1. This is the same as -1 times 81 to the half, or -1 times the square root of 81. Where this one is the negative under the square root, not in front. Okay, so again, a bracket or a bracket missing, are the answers the same or different? Different. What are the 2 answers?
If
this one, the whole thing is squared, right? So if we wrote the power out, this would be 3x to the 2 over 2, because that's a squared. So this would be just 3x to the 1. Now what about this one? Right, and the square root of x squared. You can't do this one, so you would leave it, and this is x. So root 3 times x, not under the root. Like, you'd need a calculator, or you'd leave it as root 3.
But it's written as x square root 3, or?
X times square root of 3, yeah. Like this. Okay, here's 15 and 16. All right, so the first one. Anyone get an answer? So what's this equal?
X minus 3.
X minus 3, because the x minus 3 is in a bracket and it's squared and we want the square root. So this would be just x minus 3. And then we have a plus x minus 3. So we've got x plus x is 2x. Minus 3 is minus 6. So that would be your answer. What about the next one? This? 4x squared. You can do the square root of 4 and the square root of x squared. So 2x. Square root of 4 is 2. Square root of x squared. Now what's that minus in front of this bracket do? Minus 2x and minus 1, right? So this is 2x minus 1. Be careful of that. 2x minus 2x is 0. They cancel, so the answer is minus 1. Whoops. All right, and we'll just finish up with a couple more. All right, so we've got 4 questions here. So cube root instead. So this could go for any root, 4th root, 5th root. How does it work? Instead of square root, which is 2 numbers to give the whatever's under the root, we need 3. So what 3 numbers multiply to give 8? 2. 2 times 2 times 2. Or 2 cubed is 8, so the answer to this is 2. What about this one? No, not undefined. It is -2 because when it's odd, Negative 2 cubed is negative 8. So odd roots you can have a negative under, not even. And you can get negative answers. So this is negative 2. So you should write that down. Odd roots. All right? So odd roots can be negative. There's no, you can plug anything into an odd root. That would be cube root, fifth root, seventh root, 365th root, right? What about this? So the bottom is the root. So this is saying the cube root of negative 8 squared. I would probably put the squared outside. Cube root of negative 8 is what? Negative 2. And then we want negative 2 squared, which would be negative 2 times negative 2, positive 4. This one is it a cube root?
Yes.
No.
Oh, no.
See, the number on the bottom is the root, so this is the square root of 49 cubed. Square root of 49 is 7, and 7 cubed I don't know, so I would leave the answer like that. Although you could write it. Yeah. 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 So you can do all the homework for that. Remember, it's due on Monday in class. And our test is Tuesday. My office hours are Monday, so you'll want to, if you have any questions, come and see me in my office hours.
That's Tuesday, real time, or?
8:30, yeah.